the roots of a function are where it crosses the x-axis. So if we have a function, so it's a cubic function, it's got up to 3 roots, 3 points where it crosses the x-axis, and at each of these roots, so the root is here, on one side of the root, we're going to have a positive, on the other side, a negative. So because it goes through the x-axis, on one side's positive, the other's negative. So we can use this to find roots. And this question says, show that the equation f of x equals 0 has a root, alpha, in the interval, so between 1.4 and 1.5. So if we do f of 1.4 and f of 1.5, because they're on either side of the root, one should be positive and one should be negative. And I should say that this only works for continuous functions. So if we had an asymptote, so if it was something like this, we can see we've got a positive here and a negative here, but it's not a root. It doesn't cross the x-axis because it's not continuous. So all we have to do to show that we've got a root is to substitute these into our function. So it's 1.4 cubed minus 4 times 1.4 squared plus 3 1.4s plus 1. So we get 0.104. And then the same for the 1.5. Because the first one was positive, this one will have to be negative. And it's negative 1/8. So we've got a change of sign, and it is a continuous function. Therefore, there is a root in the interval 1.4 to 1.5. Part B says, by considering a change of sign, verify that alpha is 1.445 to 3 decimal places. So we've got 1.445 to 3 decimal places. We're going to use the bounds. So the upper bound and lower bound for alpha. So the lower bound for alpha is 1.4445. And the upper bound for alpha is 1.4455. So that's the upper and lower bound for alpha. We just need to substitute them in, and we should get a change of sign. So if we do f of 1.4445, so substitute it in, and we get a positive 1.2 times 10 to the power of negative 3. And then f of 1.4455 negative 1.1 times 10 to the power of negative 3. So again, we can see we've got a change of sign and a continuous function. Therefore, the root is, therefore, alpha equals 1.445 to 3 decimal places. One for you to try. Give it a go. So if we've got a root in the interval 1 to 2, between 1 and 2, we should get a change of sign. So if we substitute in 1, substitute in 2, if one's positive and one's negative, that means that cross x between them. If it is a continuous function, which it is, so let's do f of 1 and f of 2. So we have 1 cubed plus 1 squared minus 2 1s minus 3. That's negative 3. And for 2, we get 5. So we've got a change of sign. And it's a continuous function. Therefore, alpha is between 1 and 2. By considering a change of sign, verify that alpha is 1.547 to 3 decimal places. So for part B, we're going to do f of 1.5465 and f of 1.5475. So the upper bound and the lower bound. So we get a negative for the first one, negative 2.6 times 10 to the power of negative 3. And for the second one, we get a positive 5.6 times 10 to the power of negative 3. So we've got a change of sign and a continuous function, which means alpha is 1.547 to 3 decimal places. Here we have another question. This time f of x is sine x plus log x, and we need to show that it has a stationary point in an interval. So it's different. A stationary point is where the gradient equals 0. It's not where it crosses the x-axis, it's where the gradient is equal to 0. And if we have a turning point, the gradient is equal to 0 at the turning point. And on one side of the turning point, we've got a positive gradient. On the other, we have a negative gradient. So we're going to find the gradient function and then see if we've got a change of sign in the gradient between 2 and 2.2. If we have a change of sign, there must have been, at some point, a turning point, if it's a continuous function, which it is. So we have the gradient function. Sin x differentiates to give cos x. Log x differentiates to give 1 over x. So we're going to substitute in 2 and substitute in 2.2. So we have cos 2 plus 1 over 2, which is 0.08 and so on. And for 2.2, we have negative 0.13. So we can see we've got a change of sign and a continuous function. So we have alpha is between 2 and 2.2. By considering a change of sign, verify that alpha is 2.074 to 3 decimal places. So we're going to put in the upper bound and the lower bound. So it's 2.0735 and 2.0745. So we should get a change of sign, which would mean the turning point is between these two values. So 2.0735 we get 4.8 times 10 to the power of negative 4. And for the upper bound, we get negative 6.3 times 10 to the power of negative 4. So again, we've got the change of sign, and it is a continuous function. Therefore, alpha is 2.074 to 3 decimal places. And a question for you to try, see if you can give it a go. So again, we're looking for a stationary point, which will be a turning point. This time the interval is between 0.7 and 0.8. So we want the gradient function. We don't want the original function. It's not a root. It's not where it crosses the x-axis. We want to know where it turns. So just differentiate it, times by the power, take one off the power. And then we'll substitute in our 0.7 and 0.8. So it's 6 times 0.7 squared minus 6 0.7s plus 1. So we get negative 0.26. And for 0.8, we get 0.04. So again, we have a change of sign and a continuous function. Therefore, alpha is between 0.7 and 0.8. Verify that it's 0.79, f of 0.785, and f of 0.795 to the upper and lower bound. So we get negative 0.01. And 0.02. So again, we've got the change of sign and a continuous function. So that means that alpha is 0.79 to 2 decimal places. A different question. On the same axes, sketch the graphs of x squared plus 3 and 1 over x. So we're going to sketch the graphs. So x squared plus 3 is our x squared graph. Move up 3 spaces. So it's that graph. 1 over x is this shape. So there are graphs. Write down the number of roots for the equation. X squared plus 3 equals 1 over x. So the roots are going to be where these two graphs intersect, where our first graph is equal to our second graph, where they meet. And there's only one intersection, so there's one solution. One intersection means this equation has one solution, so one root. One for you to try, see if you can give it a go. So on the same axes, sketch the graphs of y equals ex, so our exponential graph, and 2 minus 3x. So y equals e to the power of x takes this shape. So it crosses y at 1, and it never touches the x-axis. It's an asymptote. It gets closer and closer, but never touches it. 2 minus 3x is going to cross at 2. It's got a gradient of negative 3. So it's going to come down like this. I should probably write down where my second graph crosses x. So it crosses x when y equals 0. So it'll be 2 minus 3x equals 0. So x is going to have to be 2/3. So write down the number of roots. How many intersections? There's one intersection, therefore one root.